folks, welcome to this series of AWS services where we are talking about VPC and networking. So by now we have talked about the VPC, we have talked about the subnets, we have seen that how the traffic flows across a VPC and the various services like gateways. Now this is time to create your own VPC. We'll start with a simple VPC with a single public subnet. So we are going to create a public subnet within a VPC, which looks something like this. So within my AWS account, there would be VPC. Within our VPC, we'll have a public subnet. Public subnet would mean that the instance that we'll create there should have an public IP, and there should be an internet gateway attached to the VPC, and there should be a route in the route table towards the internet gateway, so that instances within the public subnet can communicate through the internet. So for this kind of architecture, AWS provides a very short way to create this kind of. So for this kind of architecture, AWS provides a very simple way to create it using something called VPC Wizard. So let's switch to our AWS console and go to the VPC dashboard. So now here we are on the VPC dashboard. We are creating it in the region Oregon. So once we are in the VPC dashboard, we can click on the Start VPC Wizard. So VPC Wizard basically creates ready-made architecture which are in common use. So one of the architecture it supports is this simple VPC with a public subnet and which has internet traffic enabled using internet gateway. So we're going to use this VPC Wizard. So you can see the details here. It is saying that it is going to create a VPC which has /16 mask, and it is going to have your instances configured in such a way that they use internet gateway and can communicate with internet. So I'll just select here. Now here you've got CIDR block of the VPC. So this itself is giving an address. Having said that, you can change it. We are going ahead with the IPv4 only, though there is a mechanism to use IPv6 addresses as well. So I can provide a name. Again, I'm just going with the name My Demo VPC. Now within the VPC, it is going to create now a public subnet. And now once again, look at the CIDR block of the subnet. This CIDR block of the public subnet has to be subset of the CIDR block of the VPC. So here, if you think about it, this is a smaller network or a smaller range of IP addresses than this. And all the IP addresses that belongs to this group, they must belong to this CIDR block as well. Now I can select the preferred availability zone. So here there are 3 availability zones in this region. So I can select any one of these. I'm going with US West 2A and the name of the subnet. For the sake of simplicity, I'm going to make it Demo Public Subnet. For now, I'm not going to create any service endpoint here. Do you want to give DNS host name to your instances? I'm going to enable it. And then what would be the hardware tenancy? Which means, are you going to create your resources within the VPC on dedicated hardware or on a shared hardware? So the default is for shared hardware. Dedicated is for the dedicated hardware for all the resources within the VPC. So I can go ahead and create VPC. And here you go. Now VPC has been successfully created along with the subnet in it. Now it is asking us to launch an instance in the subnet that we just created. We'll do that, but before we proceed, let's look at what we created. So in the VPC section, you can see My Demo VPC. And this is the CIDR block associated with this. This is the VPC ID that got created. And further, these are the various configurations associated with VPC. So when you create a VPC, a main route table and network access control list is anyway gets created along with the VPC. So this is the associated route table and this is the associated access control list. Now let's look at the subnets. Go to the subnet section and here you can see we have created a demo public subnet. This is created in the availability zone US West 2A and the CIDR block is this. Since it has got /24 mask, so it can create 251 valid IP addresses within this subnet. And this is the associated VPC. So this is how you differentiate a subnet by looking at to which VPC it belongs to. Now you can see the route table and here you go. In the route table, one of the route is for the destination within the VPC, and one of the route is pointing towards the internet gateway. So as we discussed in the last section, that to ensure that your instances gets connected to instances, you also need to make sure that there is a valid route towards the internet gateway. Now this is a public subnet and it has got a route to internet gateway. And then we have got network ACL and flow logs. Now let's see that what happened to internet gateway. If you go and click on internet gateway section, here you can see that you have got two internet gateway. One was for the default VPC that already existed in my account, and this is the one that we created. So internet gateway is fully managed by AWS. It doesn't need to show any of its properties. So it has got just minimal properties. The only thing that it tells is that it has been associated with the VPC. Other than that, you can put your tags, labels, etc. on the VPC. Okay, so internet gateway is there and it is attached to my demo VPC. So must be working fine. Only way now to ensure that this is working fine is if we launch an EC2 instance in this particular subnet. So let's go to the instances and try to launch an EC2 instance and see if it is possible to select the new subnet and the new VPC while creating the EC2 instance. So I'm going to launch an instance here. I can select a normal AMI and T2.micro instance type. So till there it was live as usual. And now here in the network, I can see a default VPC and my newly created VPC, which is called my demo VPC. So I can select this VPC. And now within that VPC, I have got only one public subnet, which is named as demo public subnet, which belongs in US West 2A availability zone. So here in the subnet setting, it seems the auto assigned public IP is disabled. And that is why it is showing here use subnet setting, which is disabled. Ideally, if you are calling it public subnet, then it should have auto assign public IP as enabled. But having said that, we can still use auto assign public IP enable because ultimately we want to connect to the internet using this instance. If it's a public subnet, that means we should have the instances with the public IP and that should be able to communicate to the internet. So for rest of it, I can go ahead as usual. Here I'm just going to give it a name, my demo instance. I just need to log in using SSH. So I'm not going to change anything here. I'm going to review and launch. I'll quickly create a new key pair. Because I don't have a key pair in this region, I have never used this region. My demo instance KPA and then download key pair and then launch instance. We can go and view instances now. So since we enabled the public IP there, we got a public IP here. And I will quickly use my puttygen to convert my PEM file into PPK file. And then I will use putty to connect to this EC2 instance. So I'll just need my puttygen. And now I'll use my putty to connect to this EC2 instance the usual way. And here you go. We are now connected to our EC2 instance. If you want to see that whether it's able to connect to the internet, we can just do ping google.com. And here you go. You are getting a reply, which means it is able to connect to the internet. In fact, you can further ensure that it is connected to the internet by installing some packages. So I can do yum install httpd-y. Okay, I have to be root. Here you go. It is just downloading the package from internet and installing httpd on my EC2 instance, which means it is properly connected to the internet. This has been possible because first thing, we have a public IP attached to the instance. Second, we have got an internet gateway attached to the VPC. Third, we have got a route table which has a route towards the internet gateway, and that route table is associated with the subnet in which we have launched this instance. And fourth and most important thing is that in my network access control list, I have allowed all the traffic. So finally, you can see that in this region, I have got now two VPCs. One was a default VPC created by AWS. Another is the one we created just now. And then it has got two internet gateways. Again, one is for default VPC, one is for us. Then it has got four subnets. Three of them belongs to the default VPC, and one of the subnet is our subnet that we created as part of our my demo VPC. There is one running instance inside the VPC, which is running in our my demo VPC. And similarly, there is one extra network ACL and route tables inside it. So if you go and see the route tables, this has created two route tables, but we have got only one public subnet. So if you see the structure of this last one is the default route table, which is created within the VPC. And if you see the route, it has got only one route, which enables it to connect to instances within the same VPC. Now, for enabling the internet connectivity, it created an extra route table where it has given the route towards the internet gateway, and it has associated explicitly to the demo public subnet. So this means the demo public subnet that we have created, that will follow this particular route table, the routes given in this particular route table, because this subnet is explicitly associated with that route table. So even though here we have got a default route table, this is not being used as of now by my instance. So if you compare it with our diagram, what we have created is we've created a VPC, a public subnet in it, and we can see that we have got a custom route table associated with this, which has got a route towards internet gateway. We have got an internet gateway attached to that VPC, and so we are able to connect to the internet from that EC2 instance. Now, only thing lacking is that we can create an elastic IP and associate it with our EC2 instance. So I can go ahead here, allocate new address, and once the address gets allocated, I can just close it and then select the elastic IP and associate this address to an existing instance. So here, this is my instance. I can just click on associate. And now if I go and see my instance, here itself it says the elastic IP is attached to this instance. If I click on this instance, Then here I can see the elastic IP. This is associated with this instance. Now elastic IP, as you understand, is kind of a static IP. It's basically a public IP that gets created and now that is attached to this EC2 instance. The benefit of this is that even if I now shut down my EC2 instance, this IP will remain associated with my instance, though it will become chargeable. And next time when I start my instance, this will remain attached to my instance. So in usual way, when you do bring your system to shut down and then start it again, the public IP associated with the instance gets changed. In case of elastic IP, it does not change. So now we have got a full-fledged architecture working here. So now we have got a full-fledged VPC, subnet and instance working here. So this was just a start where we just created one subnet and one VPC. Going forward, we are going to learn more components and we are going to make more complex architectures. So see you soon in the next video. If you have got any doubt, any comments, please put it into the discussion box and we'll get back to you. So see you soon in the next video. Thank you for watching.